our region's business. Innovation, transformation, momentum, improving our communities and driving technologies that will shape our region for generations. The collaboration that brings vitality, prosperity, and life to living. Stay with us for the coming half hour as we examine in depth our region's business. Now, here's your host, Bill Flanagan.
Today on our region's business, discovering the Pittsburgh Supercomputing Center and talking with a tornado about the global impact of Carnegie Mellon's Entertainment Technology Center. But first, a new and ever more sophisticated way to detect brain injuries invented by a company called Neuro Kinetics right here in our region. The company makes non-invasive medical test equipment, and here to tell us what that is all about is Howison Schroeder, the CEO of Neuro Kinetics.
Hi there.
Hi, welcome. Good to see you.
Thank you for having us.
Yeah, this is going to be one that's probably hard to explain, but you literally, with this technology...
That is a challenge.
It's been around for a long time, over 25 years, right? But this technology allows you to understand whether the brain's been injured by what? Looking at the eyes or monitoring the eyes?
Well, the eyes, essentially, it's the only part of the brain that we can see without drilling or poking or cutting in some way, shape, or form. So the whole premise is that if you provide a specific stimulus, whether it's a light on a wall, which we call an oculomotor test, or whether it's motion, which is a vestibular test, or some other stimulus, measure the response reflex of the eye to that stimulus, then take software, take your stimulus data, your eye response data, put the two together, analyze it. It's fascinating what you can see. So it's almost like the little LED in our computers when we boot it up and it's flashing on and off, telling us that it's working and things are happening inside. Well, much more sophisticated sort of algorithm, but the eye is doing very much the same thing for the brain.
Interesting. Now, and obviously with what's going on, you know, in the Middle East, with the war and defense casualties, so much talk these days about concussions and everything else.
Yes.
Suddenly this interest in really knowing what's going on in terms of brain injury seems to be more important than ever.
Yes. Absolutely right. And it's interesting because the tests that we do have been around, many of them, for a long time. And have been done by really those who are particularly skilled in the art of a given test, what we call a saccade test or an optokinetic test, etc. And that test then really managed by a given doctor who specializes in a given sort of condition. We're taking that art, we're turning that art into science and coming up with now an objective and repeatable battery of tests, plural, because no one test seems to give us all the information we really need, and from that we can get objective, what appears to be black and white data about whether someone's been injured in a concussion or not, and how they've progressed in their healing. And
I would assume with the growth of technology and everything else, it gets better and better.
Yes. Although there's a certain point where the human function, there's only a certain level of what we need to get to in order to be better than the human and collect that data. But, so for example, one of the little sort of basic scientific premises, humans process images at 30 frames per second. So these TVs are sort of taking images about 25, 30 images a second. But the eye can move at a rough equivalent to 250 images a second. So once we get to probably 500 images per second, we don't probably need all that much more data. We're collecting data consistently every day in the clinics now at 100 to 125, and that resolution is just fascinating what we can see.
Well, okay, and can you put it in layman's terms? What you can see, what is you got a patient in there that you're suspecting there's a problem? What is it able to tell you about the patient, and also how they're doing? Are they getting better?
What's it tell you about the patient? One of the things is now we're looking at this data, and it's sort of a new presentation. Again, not many people have been able to look at it, but it can tell you in these tests that this person now has a deficit function. And what we seem to be seeing is that in this battery of roughly 20 different tests, certain tests seem to be indicative of traumatic brain injury, mild traumatic brain injury, or concussion. As we map that out, and we at Neuro Kinetics are pretty confident what we see because we're living with this every day, but now getting the medical community to adapt it and adopt it is a little more of a challenge because we got to get this clinical work. Anyway, we can essentially, and frankly we had one sort of fortuitous event where it was fortuitous for us, not for the employee, but he flew over the handlebars of his bicycle, hit his head and cracked his helmet. Now, we've all been guinea pigs. So we had baseline data for him, and then we had post-trauma data. His MRI showed that he was perfectly normal, but he wasn't, and he knew he wasn't. And the data that we collected showed a clear drop-off in his performance in these tests. It also showed where he began to heal. So sometimes, frankly, this little balance organ in our inner ear, and particularly with the soldiers coming back, the blast trauma, will throw this off. That seems to heal pretty quickly. But these other, what we call saccade tests, which are much more deep-seated neurologic functions of the brain, don't heal as well, and some don't seem to heal at all. So, in time, we think we will be able to kind of see, where are you? Are you in a position where you can go back on the playing field, where you can go back into the battlefield? We're not there yet to make that declaration, but the data suggests we will be.
And right now, the neurokinetics technology in clinical practice being used?
Absolutely, yeah. Yes. We're in roughly 17 different VAs right now across the country, and 11 DOD hospitals across the country.
And there seems to be rising interest, obviously, because of the Defense Department interest in this kind of technology.
Yes, rising interest. And actually, I was in D.C. yesterday talking to various politicians about how to kind of get a little more extra support for what we're doing. A lot of the research that the Department of Defense is doing now, pretty esoteric stuff. But we're here. We're practical. We're already doing it. We just need to sort of kind of get the buy-in from more folks to say, oh, I see it. I get it. Let's go.
Yeah, well, it's exciting, I'm sure, because so many question marks right now about the brain and how best to help it recover from all kinds of injuries, and this may indeed be part of the answer.
It's fascinating stuff, and it's just amazing what we can see.
And excellent. Howison Schroeder, CEO of Neuro, company right here in our region. Thank you so much. Appreciate it.
Thank you for having us. It's been a pleasure.
And next up, one of the fastest computing centers on Earth, right here in our region. Stay with us.